It's not uncommon for us to want to study a population that's so large and unwieldy that we can't possibly get all of the data points from the population. So to do something about that, we take what's called a sample. Now, a sample is just some selection, some subset of a population. Now, there are lots of ways that you can take samples, and depending on how you take them, they might be biased. Now, what we mean by biased is whenever a sample consistently over or underestimates some characteristic about the population, it's biased. So in order to avoid bias, what we do is we take what's called a random sample. Let's take a minute to formally define a random sample. Say we want a sample of size n. Now, each of these sample points is going to be selected under identical conditions with the same probability distribution each time. So we're going to name n independent random variables, one for each sample point we're going to select. So I'll have capital X1 up to capital Xn. Now, we can define those n random variables as a random sample of size n from the population, and we write its joint probability distribution as the product of the probability distribution for each of the independent random variables separately. And we can do that because of the independence. Now, when we have a sample, sometimes we want to know things about the sample, like the mean of the sample, the median of the sample, the mode of the sample, the standard deviation of the sample, the variance of the sample. All of these measures of location and measures of variability, or the spread of the data. All of these pieces of information are called statistics. Any piece of information about a sample is called a sample statistic. So we have the sample statistic of the mean of the sample, or the mode of the sample, or the median of the sample, and so on. Now, to find mean, median, and mode, or standard deviation, or variance, all of these things, they all work the same way that they have for an entire population mean or population standard deviation. So you can know how to do these calculations already. It's just a matter of applying them to a sample rather than a population.